Have you ever wondered about the potential consequences of merging two groundbreaking technologies, AI and quantum computers? Recently, the US government encountered a development that raised concerns and led them to request Google and NASA to shut down their quantum computer projects. This is something that many prominent figures in the scientific community, including Michio Kaku and Elon Musk, have been warning about for years.
We all know that digital computers changed virtually every aspect of our life. Well, the arrival of quantum computers could be even more historic than that. We're now in the initial stages of the next revolution. We're talking about a new generation of computers, the ultimate computer, a computer that computes on atoms, the ultimate constituents of matter itself. The question is, who's involved in this race to perfect quantum computers? And the answer is everyone. All the big players are part of this race because if they're not, Silicon Valley could become the next Rust Belt. Also, anyone who's interested in security is interested in quantum computers. They can crack almost any code that is based on digital technology. That's why the FBI, the CIA, and all national governments are following this very closely. Quantum computers will change everything. The economy, how we solve problems, the way we interact with the universe, you name it, quantum computers will be there.
So, what lies ahead? Are quantum computers and AI going to dominate the human race? Join us today as we delve into the world of quantum computers and uncover the terrifying truth that will leave you in a state of absolute disbelief.
I think the danger of AI is much greater than the danger of nuclear warheads, by a lot. Mark my words, AI is far more dangerous than nukes.
I try to convince people to slow down AI, to regulate AI. This was futile. I tried for years.
The biggest issue I see with so-called AI experts is that they think they know more than they do. And they think they're smarter than they actually are. This tends to plague smart people. They define themselves by their intelligence, and they don't like the idea that a machine could be way smarter than them, so they discount the idea, which is fundamentally flawed. That's the wishful thinking situation. I'm very close to the cutting edge in AI, and it scares the hell out of me. It's capable of vastly more than almost anyone knows, and the rate of improvement is exponential.
It feels like we are the biological bootloader for AI, effectively. We are building it. And then we're building progressively greater intelligence. And the percentage of intelligence that is not human is increasing. And eventually, we will represent a very small percentage of intelligence.
Quantum computers are fascinating machines that operate on the principles of quantum mechanics, in contrast to our familiar traditional computers, which use bits to represent information as zeros or ones. Quantum computers work with qubits. These qubits are quite different. They can hold information as both 0 and 1 at the same time due to a phenomenon called superposition. Qubits are the stars of the quantum computer world. They can exist in multiple states simultaneously thanks to their superposition abilities. This means that quantum computers can handle complex calculations in parallel, potentially speeding up tasks significantly compared to our classical computers. And there's more. Entanglement is another fascinating aspect of quantum computing. It's a phenomenon that connects multiple qubits together. When entangled, the state of one qubit becomes closely linked to the state of another, regardless of the distance between them. It's like they have a cosmic connection. So, quantum computers are not your ordinary machines. They utilize the extraordinary capabilities of qubits to process information in an entirely different way. Traditional computers use classical bits and can only work with either 0 or 1 at a time. Quantum computers, on the other hand, leverage superposition and entanglement to process a wealth of information all at once. It's like multitasking on a grand scale. If you're curious about the origins of this quantum revolution, it all goes back to the early 20th century when the captivating quantum theory took its first steps. Since then, scientists have been on an exciting journey to unlock the full potential of quantum computing. Quantum theory delves into the tiniest building blocks of our universe, namely atoms and subatomic particles. This branch of physics introduced a new perspective called quantum mechanics, which completely transformed classical physics. In 1900, Max Planck proposed the radical idea that energy comes in discrete little packets called quanta, rather than being a continuous flow. Think of it as energy coming in small energy snacks. This groundbreaking concept laid the foundation for understanding that particles like electrons can only exist at specific energy levels, with no in-between states. In 1925, Werner Heisenberg added to the quantum revolution with his famous uncertainty principle, which essentially says you can't have it all at once. According to Heisenberg, we can't simultaneously determine the exact position and momentum of a particle. The quantum world is full of surprises, embracing probabilities and keeping us guessing. In 1935, Albert Einstein, along with Boris Podolsky and Nathan Rosen, introduced the EPR paradox, a thought experiment that challenges our understanding of entangled particles. It raised the idea of spooky action at a distance, where entangled particles appear to communicate instantaneously, regardless of their separation. It's like quantum teleportation, giving us all a good dose of scientific wonder. But the story didn't end there. The revolutionary concept of quantum computing emerged in 1980, introducing computers that harness the mystical powers of quantum mechanics to perform astonishing calculations. In 1982, physicist Paul Benioff had a brilliant idea, envisioning a new type of computer that could harness the incredible power of quantum mechanics. These quantum systems could perform mind-boggling computational tasks, making our regular computers look slow by comparison. The excitement for quantum computing only grew from there. In the same year, physicist Richard Feynman became quite enthusiastic and expanded on Benioff's ideas. He saw the potential of quantum computers to solve problems that would leave classical computers scratching their heads. Feynman's visionary thinking sparked curiosity in the scientific community, laying the groundwork for further exploration and research in quantum computing. Over the following decades, researchers delved into the details of quantum mechanics, understanding the principles behind this technology. In 1994, mathematician Peter Shor unveiled a groundbreaking algorithm that showcased the true potential of quantum computers. It was like cracking a secret code, allowing quantum computers to handle complex calculations much faster than their classical counterparts. The year 1998 marked the first practical glimpse of a quantum computer. A team of researchers at the Los Alamos National Laboratory created a 2-qubit quantum computer using nuclear magnetic resonance techniques. While it had limitations, it marked a crucial milestone in the journey of quantum computing. Fast forward to the early 2000s, an era of quantum computing progress. Multiple research groups and companies aimed to create more advanced quantum computers, and they achieved some breakthroughs. In 2001, the IBM team achieved a significant milestone by presenting the IBM Qubit, a 7-qubit quantum computer that impressed scientists and tech enthusiasts. Subsequently, the quantum community delved into quantum error correction, aiming to protect quantum information from the interference of the environment. They developed codes like the surface code, providing qubits with a protective layer that made quantum computers more reliable. By 2005, researchers at the University of Innsbruck and the National Institute of Standards and Technology built a working quantum computer with 5 qubits. While some might say only 5 qubits, it represented a quantum leap, demonstrating that practical quantum computers were within reach. The quantum journey didn't stop there. In 2007, scientists at Yale University made strides by creating stable qubits using solid-state systems, which are more stable and manageable materials. This discovery was like finding a new recipe for entering quantum stability, making quantum computers more user-friendly. In 2010, the University of Science and Technology of China achieved something straight out of science fiction: quantum teleportation. Not teleporting people, but quantum information from one particle to another 10 miles away. This showcased the potential for building quantum networks, where quantum information could travel great distances. In 2013, Google and NASA joined forces to develop the D-Wave 2, a groundbreaking quantum computer. However, as the project gained momentum, an unexpected government shutdown hindered its progress, leaving the quantum computer in a state of uncertainty. Turning the computer off and on again when things returned to normal would be costly and time-consuming. Google also found itself in a confusing situation. Turning the computer off and on again when things returned to normal would be costly and time-consuming. Google also found itself in a confusing situation, having invested in the Ames Quantum Artificial Intelligence Lab, which granted them access to the quantum computer. With the lab closed, their future plans were uncertain. The government shutdown took its toll on the project, forcing NASA's exploration of this exciting technology to come to a halt. Despite these setbacks, the story doesn't end here. With government operations back on track, the D-Wave 2 quantum computer and the dream of exploring the quantum frontier are poised to bounce back. In 2019, Google made headlines with quantum supremacy, demonstrating the remarkable power of quantum computers for specific tasks. This breakthrough inspired other tech giants like IBM and Microsoft to intensify their efforts in the quantum realm, creating a competition to build better and more reliable quantum systems. In 2020, IBM unveiled the IBM Quantum System 1, the first fully integrated quantum computer designed for commercial use. This marked a significant step towards practical and accessible quantum computing, attracting attention and investments from governments and industries worldwide. Governments couldn't resist the allure of quantum technology and recognized its potential for game-changing applications. This led to the funding of quantum research initiatives and the establishment of research centers and labs that have become hubs for collaborations among academia, industry, and government agencies. In the modern scientific community, there's a belief that intelligent life might exist on other planets, possibly using black holes as powerful supercomputers. The Fermi paradox has puzzled scientists for years. If there's a high chance of life elsewhere in the vast universe, why haven't we found clear evidence of it? It's akin to searching for a needle in a cosmic haystack. The Hart-Tipler conjecture attempted to address this paradox, suggesting that if advanced alien civilizations were out there, we should see signs of their activity. However, a group of physicists from Germany and Georgia introduced a new idea, that these civilizations might be harnessing black holes for advanced technology. Since 1960, the search for extraterrestrial intelligence has focused on scanning the cosmos for radio signals. However, some researchers propose broadening the search to include other signs of advanced technology, such as directed energy, neutrinos, quantum communications, and gravitational waves. The study by Giadvali and Zaza Osmanov explores the idea of large-scale quantum computing as a potential means of detecting advanced alien civilizations. Quantum computing, known for its rapid information processing and robust security, is considered an ideal choice for advanced civilizations. These hypothetical civilizations may utilize black holes as perfect environments for quantum computing driven by the laws of quantum physics and gravity. These small black holes, potentially created by advanced aliens, would emit intense radiation, including Hawking radiation, named after physicist Stephen Hawking. This radiation, including high-energy neutrinos, could serve as a sign of advanced civilizations, according to Diwali and Osmanov. These high-energy neutrinos might originate from both Hawking radiation emitted by small black holes and particle collisions used to create them. To detect these signals, the IceCube Observatory, located deep in Antarctica's ice, could play a crucial role. This groundbreaking theory might provide an answer to the Fermi paradox, explaining why we haven't encountered signs of advanced civilizations. If these cosmic neighbors have shifted from traditional communication methods to using black holes as their quantum supercomputers, it explains our lack of detection. As computing technology advances, these civilizations may use radio signals for only a limited time, a factor represented by the L parameter in the Drake equation, which reflects how long civilizations actively send detectable signals into the cosmos. Michio Kaku, a prominent theoretical physicist, recently shared insights into quantum computing. He highlighted the potential of quantum computers to verify the accuracy of information generated by AI chatbots. These quantum machines could enhance the reliability of results, but Dr. Kaku expressed concerns about the control of this fact-checking power, as governments could potentially manipulate information and suppress opposing viewpoints. It's a complex dynamic, and ensuring the responsible use of such technology is paramount. Now let's delve into the complex world of quantum computing. It's a double-edged sword, with the potential to greatly benefit society, but also the power to be misused for control and deception. AI development has soared forward, bringing us advanced tools like AI image generators and chatbots. But this high-tech wonderland also has its dark side. Deepfakes, for example, spread false political information like wildfire, creating super-realistic but fabricated content that blurs the lines of truth. These deepfakes can be used to incite chaos by generating false orders and misinformation in international conflicts. Law enforcement AI tools can exacerbate this issue, leading to over-policing and biased decisions, especially impacting marginalized communities. The inherent bias in AI models only worsens social inequalities. Even AI language models can generate false information, potentially causing harm. Additionally, AI trading bots can disrupt the stock market. But there's no need to panic. Scientists worldwide are on a mission to build the ultimate quantum computer. It's a challenging endeavor, which might take several more years, even a decade, to become a reality. The timeline depends on technological breakthroughs, new discoveries, and of course, having the necessary resources. They're pursuing two main approaches. The first is gate-based quantum computing, which involves controlling individual qubits to perform calculations. They're striving to create more stable qubits, like superconducting circuits and trapped ions, while minimizing errors. The second approach is adiabatic quantum computing, which gradually evolves a quantum system to solve complex problems through quantum annealing. Researchers are experimenting with different materials and specialized devices to enhance the performance and scalability of adiabatic quantum computers. However, quantum computers are sensitive to their surroundings and prone to errors. Maintaining quantum coherence is essential for accurate computation, requiring highly controlled and isolated environments at super low temperatures, which is a costly and challenging endeavor. Error correction is a critical aspect of quantum computing, as errors can affect the accuracy of results. Scientists are actively researching ways to tackle these errors and enhance the reliability of quantum computers. Governments, academic institutions, and private companies are collaborating and investing heavily in quantum research and development. Initiatives like IBM Quantum, Google Quantum AI, and Microsoft Quantum are leading the way, providing researchers with access to top-notch quantum hardware, software, and educational resources. In the ever-evolving world of quantum computing, scientists are constantly innovating and developing new quantum algorithms and software, bringing us closer to a quantum wonderland. Let's talk about the applications of quantum computing. They have the potential to revolutionize various fields, including optimization problems, machine learning, cryptography, and drug discovery. Quantum computers can outperform classical computers, acting as cosmic superheroes in the world of technology. In the realm of space exploration, quantum computers are invaluable for simulating and modeling astronomical phenomena. They can perform complex simulations faster and more accurately, providing deeper insights into celestial bodies and cosmic interactions. This enhances our ability to plan space missions with precision, optimize trajectories, and predict space debris movements, ultimately leading to improved mission success rates and safety. Quantum computers also have a profound impact on cryptography, a critical component of space exploration. Traditional cryptographic algorithms may become vulnerable to quantum attacks. Quantum cryptography, leveraging quantum properties like entanglement and superposition, ensures secure communication channels, protecting sensitive information during space missions. Beyond secure communication, quantum computers possess incredible abilities such as quantum tunneling, enabling more efficient spacecraft propulsion, and quantum simulation and modeling for optimizing logistics, materials design, and simulating nuclear reactions. Machine learning on quantum computers enhances decision-making, pattern recognition, and autonomous systems, aiding in mission planning and resource allocation. Quantum computers aren't just tools, they're cosmic enablers, opening new horizons in space exploration, security, and technological advancement. Let's not forget about quantum sensors. They're like advanced cosmic trackers, enhancing target detection and tracking with exceptional precision. Quantum communication acts as a cosmic security system, ensuring real-time analysis and data processing on the battlefield. This leads to top-notch situational awareness, enabling well-informed decision-making in cosmic conflicts. While quantum computing is still a developing field, it holds the potential to greatly enhance military capabilities. However, alongside the promise of quantum computing come potential threats and challenges that demand our attention. One major concern revolves around the threat to encryption systems, which play a fundamental role in securing sensitive information and safeguarding data privacy. Many secure communication protocols, such as those used in online banking and government agencies, rely on complex mathematical processes to maintain data security. Classical computers struggle with these calculations, making encryption quite secure. However, quantum computers introduce a game changer. They have the potential to break these encryption schemes using algorithms like Shor's, which can factor large numbers rapidly. If quantum computers fall into the wrong hands, confidential information like financial records or classified data could become vulnerable to malicious attacks. Another area of concern is the world of cryptocurrencies, with Bitcoin being a well-known example. Cryptocurrencies use cryptographic algorithms to secure transactions and protect the integrity of digital currency. Quantum computers could potentially break these algorithms as well. In the future, if quantum computers become powerful enough, they might undermine the trust and reliability of cryptocurrencies, which could lead to disruptions in the digital economy. As we delve deeper into the quantum world, we must confront these encryption challenges head-on. Scientists and experts worldwide are tirelessly working on new cryptographic methods referred to as post-quantum cryptography to defend against potential quantum threats. The battle between quantum computers and encryption is a cosmic dance, a never-ending struggle. However, we are committed to keeping our data secure and maintaining stability in the digital realm. Quantum computers, while promising, also introduce potential threats to the core of the Internet. Internet security heavily relies on public key cryptography to protect online communication, transactions, and data transfers. The cosmic dilemma is that quantum computers can break encryption algorithms, rendering these security measures ineffective. Imagine sensitive information exposed and cyber attacks becoming rampant, shaking the foundations of e-commerce, online banking, and overall trust in digital interactions. Furthermore, data privacy comes under scrutiny. With their immense computational power, quantum computers could unravel patterns and correlations within large data sets, even if they're encrypted or anonymized. This poses a cosmic challenge for individuals and organizations relying on data privacy to protect personal information or trade secrets. We're talking about potential breaches of data privacy, raising concerns about ethics and the need for regulatory frameworks to protect our rights and prevent the misuse of sensitive information. Quantum computers can even disrupt the foundations of scientific simulations and models. Their power could potentially undermine the integrity of these simulations, leaving scientists and researchers with uncertainty. Quantum simulations hold great potential, promising revolutionary advancements in fields like material science, drug discovery, and climate modeling. However, here's the concern. If quantum computers become powerful enough, they might break through the encryption protecting these simulations. Imagine unauthorized access to sensitive information or worse, altering the results. This cosmic challenge could seriously impact scientific research, innovation, and decision-making. But don't panic just yet. Our cosmic heroes are on the case. Scientists, cryptographers, and experts are actively developing quantum-resistant encryption methods, known as post-quantum cryptography, to protect our digital world. They're working to ensure that when the age of quantum computers dawns, our digital interactions remain secure. So, while quantum computers unlock new realms of computation, they also challenge us to enhance our efforts in safeguarding the digital landscape of our cosmos. This cosmic duel between quantum computers and encryption technology compels us to keep pushing the boundaries of security in the digital world. As the quantum revolution takes place, our digital fortresses need to evolve to withstand new threats. In response to the quantum encryption challenge, a global community of experts and researchers is working tirelessly to pioneer post-quantum cryptographic methods. These advanced encryption techniques aim to provide a robust shield against the formidable computational abilities of quantum machines. Thanks for tuning in to explore the fascinating intersection of AI and quantum computing. If you found this video interesting, don't forget to hit that like button and leave a comment to share your thoughts.